Let's move on to Geometry Lesson 9.3, and we'll be working on surface areas of pyramids and cones. So our last lesson, we were working on prisms and cylinders that had two bases. Surface areas of pyramids and cones only have one basis. Here's the slide that, sorry about that, that has as many of the formulas listed that I saw in this lesson. There may be a few more, but the basic formula that we'll be using is S equals L plus B instead of 2B. With regular pyramids, there's another formula can be derived, and so forth. Now, you can see here that some of these formulas have the same description. That means that more than one formula can be used depending on the amount of information that you have. There are also more specific formulas for lateral surface areas, so we'll get into that. So pyramids. Pyramids are cones with polygonal bases, and they're classified by those bases. So this pyramid would be a pentagonal pyramid because it has a pentagon as its base. And it will have a face attached to each side, which means it has 5 lateral faces and 1 base for a total of 6 faces. Each one of those lateral faces is a triangle, and all of those triangles are congruent. The lateral edges are the segments formed by the intersection of the lateral edges. So a lateral edge would be AE, AF, AB, AC, AD. The segments from the vertex that are perpendicular to the plane of the base is the altitude. So a line from A down to the base, and the base is BCDEF, you can see is dropped so that it's 90 degrees, and that is the altitude of this pyramid. Lateral edges such as AC and AE intersect at the pyramid's vertex, which is point A. So the altitude's length is actually what we call the pyramid's height. To measure how high this figure is, you do not use these edges. What you'll use is the perpendicular that's dropped. So what we've also known as the altitude, we are calling the height, which is big H. This height is typically not the height of any of these faces. So for almost all of these figures, it will not be the height of the triangular faces, which will actually be another measurement that we'll take. The surface area of any pyramid consists of the lateral surface area and the area of the base. So the overall formula for solving the total surface area of a pyramid is S equals L plus B. So let's take a look at a net of this pentagonal pyramid, or this is actually a square pyramid. It has a square base, and the area of that square is side by side. Each one of these triangles is congruent to the other. They each have the same side length, which is the same lengths as the base, and they each have a height or an altitude that's dropped on each base. Now, so that we don't confuse these with the altitude that's dropped inside of this pyramid, this is called L, the lateral surface. And we also call it the slant height. So from now on, we'll refer to this as slant height. So if you look at the triangle, you see that it is slanted, so this makes sense. It will drop from the vertex of the triangle to the base at a 90-degree angle. So when calculating the area of the lateral face, we'll use the slant height L and the height, which is the height of the triangular lateral face, and not the altitude or height of the pyramid. So we will not be using this height of the pyramid. A regular pyramid is a right pyramid that has a regular polygon as its base. The heights and bases of the congruent triangular lateral faces are identical. I already explained that. And but it's very important for you to know that when you're working on these formulas. Use the slant height L and the length of the base to find the area of one of the isosceles triangles. So when we're solving for B, we'll just find one area because they are all congruent. We'll multiply that area by the number of the sides of the base. So let's put that into practice. We are going to find the surface area of a regular pyramid. This is a pentagonal pyramid. We have a slant height of 16 inches. We have a side length of 7 inches. And we have an apothem length of 4.8 inches. And we need that apothem length because we're going to be solving for area of the base. So we'll begin by solving for one of the triangular faces. So area of the triangle equals 1/2 base times height, and it'll be 1/2 the base edge here, which is 7, times the height, which is the slant height, which is 16. That'll be 56 inches squared. Now we'll look at the lateral surface area, and that would be the number of those triangles. So the number times the triangle. We know that this triangle was 56 inches squared, and there are 5 triangles because there is a triangle attached to each side of this pentagon. So 5 times 56 is 280 inches squared. And now we'll solve for the total surface area, which is S equals L plus B. So example 1, let's put what we just learned into practice. We're going to find the surface area of the regular, and this is a pentagonal pyramid. We'll begin by solving for the area of one of the triangles. So the area of the triangle is 1/2 base times height, which is 1/2 7 times, and it's this slant height length 16, which is 56 inches squared. Now we'll solve for the lateral area, which is the total number of those triangles times the base, the area of the triangle. So we have 5 triangles, 5 triangular faces, times the answer we found for area of the triangle, which is 56, and that gives us a lateral surface area of 280 inches squared. Now we'll solve for the area of the base, and this is a pentagon, so the area formula is 1/2 AP. That's 1/2 4.8, and then it's P, if you remember, is really NS, so the number of sides is 5 times the side length, which is 7. 1/2 4.8 times 35 is 84 inches squared. And now we can put it all together. The total surface area will be the answer from the lateral surface area, which was 280, plus the answer from the base, which was 84, and our final answer is 364 inches squared. So here's one of the formulas we can derive for lateral surface area of a regular pyramid. So this will apply to a regular pyramid, and you will solve for the number of triangular faces. the area of the triangular faces times the number of sides. So that will be 1/2, and the area of a triangle is BH. So it'll be the number of sides times 1/2 BH. But now, according to the drawings we've been using, instead of a base, we're using side. Instead of height, we're using slant height. So now the formula will be 1/2 n, the number of triangles, times 1/2 SL, which is now the area of the triangle. And if we use our commutative property to move our pieces around, we can see that we can have here 1/2 NS, which is perimeter, and we have 1/2 NS times the slant height, or 1/2 PL. So any one of these pieces could be used, but our new derived formula for the lateral surface area of a pyramid is 1/2 PL. We also have a derived formula for the total surface area of the pyramid. And remember, we now have the 1/2 PL. Well, the base was 1/2 AP. And if you notice, you have two 1/2s here, and you have two P's. So we can pull those out using distributive property, and our total formula now for total surface area of a regular pyramid is S equals 1/2 P times L plus A. So that's another one that you can use for this, and this is the most specific formula. Theorem 9.3.1. The lateral surface area of a regular pyramid is 1/2 PL, which we've just derived, and the surface area is 1/2 PL times slant height plus apothem, which is also what we previously derived. Example 2. We have a hexagonal pyramid. It says find the lateral surface area and the surface area. So find the perimeter of the base first. Find the lateral surface area using the slant height of 23 inches. And with hexagons, we do these a little differently. You have to divide the hexagonal base into 6 congruent equilateral triangles. Each apothem forms a 30, 60, 90 triangle. We've been using this since chapter 7, and bisects a base edge. The longer leg of that triangle is square root of 3 times the shorter leg we've learned from using our ratios, and then we find the surface area. So those are the actual steps for solving this particular pyramid, and let's do it. So we're going to find the lateral surface area. We're going to start by finding the perimeter of the base, and the perimeter equals the number of sides times the side lengths. So it's 6 sides times 12, which is 72 inches. Now we'll find the lateral surface area using the slant height, and our new formula is 1/2 PL, so it'll be 1/2 72 times the slant height of 23, which is 828 inches squared. Now we're going to divide the hexagonal base into 6 congruent equilateral triangles. And this is what that base would look like. It has 6. If you draw your diagonals, you'll end up with 6 equilateral triangles. And if we go ahead and drop an apothem, it divides the base in half. So you now have this right triangle that has a base of 6, a hypotenuse of 12, and a long side, which according to our 30, 60, 90 ratios, this long side will be 6 square root of 3. So the apothem will be 6 square root of 3. That's all they asked us to find. They didn't ask us to find the total surface area. So here's just some notes that you should have as a reminder. A prism is a cylinder with polygonal bases. A pyramid is a cone with a polygonal base. For prisms, a formula was developed for cylinders, and a formula can be derived from pyramids to solve surface areas of cones. So we've been solving figures that have polygonal bases. Now we're going to solve figures that have circular bases. And here's an example. Take a look on the left here at this pyramid. As we move from left to right, you can see that we have more and more lateral faces. They're smaller, and as we add lateral faces, the base gets closer to becoming a circle. So as the number of sides of the base of a regular pyramid increase, the pyramid approaches the shape of a cone. The base's perimeter approaches the circumference of a circle. So we've showed this before with polygons and circles. The pyramid's apophthegm approaches the radius of a circle. So what was originally an apophthegm now becomes the radius of a circle. So let's take a look at the difference between the formulas. The left side is pyramids, the right side is cones. Lateral surface area is 1/2 perimeter times the slant height. In a cone, lateral surface area is 1/2 circumference times the slant height. Instead of saying PL, we will say CL, and instead of saying AP, it will now be RC, which we have derived before. And the formula for surface area of a circular cone will be 1/2 C times L plus R. In the formula for the lateral surface area of a pyramid, the P for the pyramid is replaced with C. P for perimeter is replaced with C. In the formula for surface area, the AP is replaced with RC. Okay? So you might want to write this in your notes, and we'll be using them quite a bit. That brings us to Theorem 9.3.2, which is the lateral surface area of a circular cone, and now lateral surface area equals 1/2 CL, and the total surface area is 1/2 C times L, which is the slant height, plus R, which is the radius. So let's use this, and example 3 says, find the height of the circular cone if its surface area is 144 pi centimeters squared. So here's an example where we're going to back solve. To back solve, we always begin the same way. We substitute known measures into the formula. This will be the formula for surface area of a cone. We'll solve the resulting equation for slant height, and then we'll apply the P theorem to determine the height of the cone, which will be H. So let's look at our formula. Here it is, S equals 1/2 C times L plus R, and we'll substitute our known values. We have total surface area already, which is 144 pi. We have 1/2, and circumference is 2 pi r. So 2 pi, and the radius is 6. So there it is, times slant height plus radius. So slant height is L, because we don't know what that is yet, plus the radius again of 6. And if we multiply 2 times 6, that's 12 pi. And now if we divide both sides by 6 pi, we end up with 24 equals slant height plus 6. And because we're solving for slant height, we want to clear the numbers next to it. So we will subtract 6 from both sides, and our slant height is 18 centimeters. Now we apply the p-theorem to determine the height of the cone because we were solving for two different things. So here's the p-theorem as we originally learned it. A squared plus b squared equals c squared. Now this a squared in a cone becomes r squared, which is the radius squared, times the height squared, times the slant height squared. Let's substitute known values. R is 6, so 6 squared. We're solving for the height. So we still have our height squared, and we know that the slant height is 18 from our last step. So equals 18 squared. If we expand, we have 36 plus h squared equals 324. We'll subtract 36 from both sides, and then we'll square. We'll take the square root, and h equals square root of 288, which is 12 square root of 2 centimeters squared, which is approximately 17.0 centimeters. A lot of steps to that problem. Example 4. Blake sells calendars in the shape of a regular dodecahedron. Find the surface area of the calendar if each face has an edge of 1.8 inches and an apothem of 1.1. So going back to what we've learned in the past, the dodecahedron has 12 regular pentagonal faces. So here's our formula for this figure. It's S equals the number of faces times the area of the pentagon. So we have 12 faces times 1/2 AP, which becomes 6 times AP, which is 6 times the apothem, and the perimeter on this figure, because they're pentagonal, can actually be expressed as 6e. That's because the pentagon has regular edges, and this is an alternate formula for a pentagon. So 6 times 5 is 30, a times e, and now we have 30 times the apothem of 1.1 times the edge of 1.8, and that is 59.4 inches squared. This is a difficult example to visualize even with the picture that they gave you. So I wanted to work that out for you, but this is another alternate formula. Be sure to record that 5e is also the formula for the perimeter of a regular pentagon. Your homework. Pages 417 to 421, numbers 1 through 5, number 7, 9 through 10, 12, 15, 19, and 44 through 47. Let's look at a few examples. Numbers 2 through 4. These problems are similar to example 3. You'll use the p-theorem. Write out the formula for the p-theorem, insert the known values, and solve for AG, AH, and HG in each one of these problem numbers. Numbers 5, 7, and 9, they ask you to find the lateral surface area and then find the total surface area. Number 6 is the cone. Lateral surface area is, for a cone, pi times the radius times the slant height. So that'll be pi times 18 times 45, which is 810 pi feet squared. Now we'll solve for the base. And the base is pi r squared. That's the area of a circle. and that's pi 18 squared, which is 324 pi feet squared. And then we'll solve for the total surface area. I have the overall formula written here, but a cone actually has a more specific formula, and I have it on the second slide of this lesson, but also here it is. Its surface area equals pi RL plus pi R squared. So we'll take our answers for lateral surface area, which was 810 pi feet squared, our base, which is 324 pi feet squared. We'll add them together, and our answer is 1134 pi feet squared. So the cones are actually fairly easy to do. Numbers 9 and 19. Here's the formula you'll use for number 9. It has a square base, so I've actually inserted the area for a square. 19. A tetrahedron is a pyramid with a square base and 4 equilateral triangles as faces. The formula will be, and we take our original formula of S equals NA, which is actually the number of sides times, and the area here is of an equilateral triangle, and I've substituted the formula for equilateral triangle, which is square root of 3 over 4 times side squared, and it'll be multiplied times 4. So the formula you'll use for number 18 is S equals 4 times square root of 3 over 4 times S squared. So I'll be available for assistance on these problems. Be sure to bring your questions to class and contact me if necessary. Talk to you again in 9.4.